Hi, Assalamualaikum to all students. Today we are going to discuss tutorial chapter 7, which covers the subtopic 7.1 acids and bases. So please refer to your answers. Alright, so this is the first question. Classify each of the following species as Bronsted acid, Bronsted base, or both. So before you answer this question, you must understand the definition of Bronsted acid and Bronsted base. Bronsted-Lowry defined acid is any substance that can donate a proton to other substance, while Bronsted-Lowry defined base is any substance that can accept a proton from other or another substance. Alright, okay. By referring to your lecture notes, there is a slide that shows helpful tips. Okay, how to recognize the Bronsted acid and Bronsted base. So Bronsted acid, it must contain a proton. It usually it is a neutral molecule, and then it could be a cations or an ions. So this answer given by using or refer to the species given in the question. So hydronium ion is the acid, Bronsted acid. Ammonium ion, hydrobromic acid, and hydrocyanic acid are Bronsted acid. They are classified as Bronsted acid. For Bronsted base is any substance. It could be a neutral molecule or neutral compound and uh, an ion. Alright. So by using the species given in the question, so hydroxide ion, NH2 minus, carbonate ion, they are an ion with negative charge. So they are Bronsted base. Okay, and they only able to accept a proton, while ammonia is a weak base. So it is classified as Bronsted base. Water, okay, water molecule, it is amphoteric, where it can act as acid and base. Okay, so water has ability to accept a proton from other substance, and it also has ability to donate a proton. So water is classified as both or amphoteric. Okay, next question. Identify the conjugate acid-base pairs in each of the following reactions. Okay, to make it simple, I use a simple notation where A is an acid, B is the base, Ca is the conjugate acid, while Cb is the conjugate base. Okay, given to you in the question, a chemical equation. Alright? Okay, to answer this question, okay, as a guideline, you may refer to the uh, conversion of the species involved in the chemical equation. Okay, let's start with question number 1. Okay, let's say you refer to the bicarbonate ion HCO3 minus. Okay, it is converted to this species, while another one, bicarbonate ion, converted to carbonate ion. Okay, so what happened to the first conversion? Let's say saya nak tengok yang ini. The green, apa? Yang saya bulatkan dengan warna hijau tu. Okay, so what happened? You can see here, HCO3 minus, okay, forms or converted to carbonate ion. And you can see it loses its proton. Jadi apa yang berlaku pada HCO3 minus? Actually HCO3 minus already donate its proton to other substance. So HCO3 minus is the acid, while carbonate ion is the conjugate base. And if you refer to the second conversion, HCO3 minus converted to H2CO3. So what happened? You can see there is an increase in the number of proton. Daripada satu proton jadi dua proton. And the charge become asalnya negative, and now the charge become more positive ataupun zero lah dalam case ni. So HCO3 minus at the left side of the equation is classified as the base, while H2CO3 is the conjugate acid. Okay, so now let's refer to the second question or second equation. We have H2PO4 minus reacts with ammonia reversibly, produces HPO4 2 minus and ammonium ion. Okay, in the second question or second equation, actually we have to classify first the acid and base. Dan you sepatutnya sebagai pelajar memang kena tahu ammonia actually is a base. Okay, so in order to answer this question, actually you have to understand the Bronsted acid and Bronsted base definition. So according to Bronsted theory, base is any substance that can accept a proton. So you can see here the conversion from ammonia converted to NH4 plus. Ammonia dia jadi NH4 plus. Jadi apa yang berlaku di situ? Ammonia telah accept proton. So protonnya daripada 3 jadi 4. And the charge become more positive. Daripada overall 0, ammonia tu neutral compound, tak ada charge. Jadi 1 positive, more positive. So ammonia is a base while ammonium ion is the conjugate acid. H2PO4 minus, okay, it is an acid. And you can see here, H2PO4 minus donates its proton to ammonia. And now it's become HPO4 2 minus. So this pair adalah H2PO4 minus adalah acid, while HPO4 2 minus adalah conjugate base. Okay. And for the third equation, okay, we have hypochlorous acid. So HClO memang adalah acid. Namanya hypochlorous acid. So it is acid. CH3NH2, if you refer to the chemical formula given, okay, for the compound, we have NH2 group. Kat sini ada NH2. So actually NH2 adalah suatu, kalau compound tu ada NH2, dia adalah suatu amine. Amine adalah dia adalah suatu base. Jadi, CH3NH2, it is a base. So base. So what happened to hypochlorous acid? According to Bronsted theory, it will donate its proton and form ClO minus, where ClO minus is the conjugate base, while CH3NH2, the base, accept the proton, which is come from HClO, and forms CH3NH3 plus. So CH3NH3 plus is the conjugate acid. Okay, so kalau tak faham, lepas ni boleh tanya lagi lah PM. Okay. Next question. Okay, by using Ka and Kb values, okay, we can distinguish ataupun bezakan. Distinguish mean differentiate. Okay, the relative acidity strength of weak acid and weak base. So what is Ka? So saya pernah sebut dalam kuliah. Ka is weak acid. Okay, dissociation constant. While Kb, okay, it is the weak base dissociation constant. Okay, so how we are going to use Ka and Kb values to compare the strength of acidity or basicity of a solution. Okay, jadi each acid, they have their own Ka values. Each base, dia mempunyai nilai Kb masing-masing. So Ka dan Kb ni hanya weak acid dan weak base yang ada Ka dan Kb. So if the Ka value greater, the solution is more acidic. Means it is a stronger acid. If the Kb value greater, okay, it is more acidic where it is a stronger base. Di kalangan weak acid. Kita sekarang ni nak compare kekuatan acid lemah di kalangan acid lemah. kita tak akan compare dengan strong acid lah. Kalau weak acid kita compare dengan strong acid, confirm strong acid tu memang stronger. Tapi sekarang ni kita nak compare the strength of weak acid tu sendiri. Okay, okay. So to helps you, okay, ataupun to guide you, we have to refer to this question. Okay, the table below lists the value of acid dissociation constant Ka for some acids at 298 Kelvin. Arrange these acids in descending order of acid strength. Jadi, kalau awak refer pada table ni, these acids are weak acid. So, at 298 Kelvin or 25 degrees Celsius, they have their own Ka values. So, ini semua adalah Ka value bagi asid ni masing-masing. Jadi, soalan suruh awak susun. Arrange the acid in descending order. Susun asid-asid ini berdasarkan turutan menurun kekuatan asid. Maksudnya, from the strongest acid to the weakest acid. Okay, so just now, I've mentioned to you, when the Ka value is greater, it is stronger acid. So, by referring to the Ka values, we can see here the nitrous acid HNO2 has the largest Ka value. So, nitrous acid is the strongest acid in this question. And the weakest acid goes to hydrocyanic acid. Macam mana tahu? Kita tengok dia punya nilai Ka. So, because the question asks you to arrange in the descending order of acid strength, so this is the answer. The strongest acid goes to nitrous acid, followed by acetic acid or ethanoic acid, and the weakest acid goes to hydrocyanic acid. Okay, next question. Okay, before we go further or discuss the next question, which is face-to-face question, saya nak ajar dulu konsep auto-ionization of water. Okay, sebab konsep ini kita perlu gunakan untuk membincangkan soalan berikut. Okay, so water undergoes dissociation very slightly. Ataupun dalam arti kata paling mudah, kita boleh kata air itu sendiri mengalami perceraian menjadi ion-ionnya very slightly. So, dia mengalami sedikit perceraian in an equilibrium. Alright. So, this is the chemical equation that shows the auto-ionization of water. So, from this equilibrium equation, okay, by ignoring, dengan mengabaikan concentration of water liquid, okay, so products of hasil darab, these ions, the concentration of the products, which is hydronium ion and hydroxide ion. So, hasil darab ini akan menghasilkan satu nilai constant yang kita panggil Kw. So, what is Kw? Ion product constant for water. So, Kw is equals to concentration of hydronium ion times concentration of hydroxide ion. And the value of Kw at 25 degrees Celsius is 1.0 times 10 to the power of negative 14. Okay, so seolah-olah ini adalah X, ini adalah X. So, kalau kita tengok X squared equals to 1.0 times 10 to the power of negative 14. So, berapakah? What is the concentration of hydronium ion and hydroxide ion in pure water? It is 1.0 times 10 to the power of negative 7 molar. Okay. And the concept of Kw will be used to compare the acidity, basicity of solution. Okay, so a change in concentration of hydronium ion causes an inverse change in concentration of hydroxide ion. Okay, tak kisahlah larutan itu acidic or basic. Okay, larutan itu berasid ataupun berbase. Dalam larutan itu mesti ada kedua-dua ion ini. Apa dia? Hydronium ion and hydroxide ion. Okay. Right? Jadi, dia ni inversely proportional. Dia ni berkadar songsak. If the solution contains higher concentration of hydronium ion, the solution will has lower concentration of hydroxide ion and vice versa. Kalau solution itu mempunyai higher concentration of hydroxide ion, its concentration of hydronium ion will be lower. Okay, by using the concentration of hydronium ion and hydroxide ion, we can compare the strength, the acidity or basicity of a solution. Okay, if the concentration of hydronium ion is larger compared to concentration of hydroxide ion, the solution is an acidic solution. If the concentration of hydronium ion is less than concentration of hydroxide ion, the solution is a basic solution. And if the concentration of uh, hydronium ion equals the concentration of hydroxide ion, the solution is a neutral solution. Jadi, nak gunakan kaedah ini kita perlukan sedikit pengiraan lah. Kita akan gunakan konsep KW ni tadi. Okay, this is one method. Okay, another method, okay, we can use pH, okay, to determine the acidity or basicity of a solution. Sebelum ni kita belajar nak tahu larutan tu berasid ke, larutan itu acidic ke basic ke, kita tengok pH. Contoh, dulu kita pernah belajar, if the solution has pH 7, it is a neutral solution. If a solution has pH less than 7, it is acidic solution. If the solution has pH greater than 7, it is a basic solution. But how the pH is measured? The pH is measured by using the concentration, the log, negative log concentration of hydronium ion. So this is the formula to calculate pH. Okay, alright. Dan kita juga boleh relate dengan pOH. Okay, pOH ni adalah negative log concentration of hydroxide ion. Tapi kalau kita nak tahu acidity or basicity, kita memang akan tengok kepada pH. And the relationship between KW, pH and pOH adalah pKW equals to pH plus pOH, which is equals to 14.00. So, P kat sini merujuk kepada negative log. Jadi, kalau pKW, maksudnya kita negative log kan KW. pH, kita negative log kan concentration of hydronium ion. OH minus, kalau kita negative log kan kita akan dapat pOH. Tapi operasi dalam log kan kalau darab kat sini tambah. Jadi ada beberapa formula inilah kita akan guna. Okey, untuk membantu awak faham, let's refer to the next question. Okay, this is the question. By using appropriate equation of dissociation, determine whether the following solutions are acidic, basic or neutral. Okay, let's say kita refer kepada soalan A, we have 0.62 molar sodium hydroxide. By using our previous knowledge or prior knowledge, pengetahuan sedia ada kita, kita memang tahu sodium hydroxide it is a basic solution. But we have to determine macam mana kita nak tentukan dia tu adalah basic solution. Okay, ada dua cara kat sini. Sama ada kita gunakan pH ataupun KW. Okay, alright. So, we know that sodium hydroxide, it is a strong base. So, sodium hydroxide, since it is a strong base, it undergoes complete dissociation. Jadi, awak kena buat equation ini. Sodium hydroxide equals, phase tu mesti ada, dissociates completely and forms sodium ion and hydroxide ion. Okay, initially we have 0.62 molar sodium hydroxide solution. So, kita buat table, initial concentration 0.62 molar. Okay, but initially we the ions masih lagi belum terhasil. So that's why kita put 0 here. Okay, and since sodium hydroxide adalah strong base which undergoes complete dissociation, so dia terus habis. So kita terus buat final concentration yang mana kat sini 0 sebab habis. Habis pergi mana? Semua sodium hydroxide itu converted and dissociates into ion. Sodium ion and hydroxide ion. So, since ratio dia 1 mol, 1 mol, 1 mol, maka kat sini 0.62 molar, 0.62 molar. Okay. Daripada table ini, apa yang kita dapat? Kita ada concentration OH minus. Yang mana concentration OH minus itu adalah 0.62. Jadi, kalau kita nak tentukan larutan ini adalah basic solution dengan menggunakan pH, Okay, kita tak boleh tengok nilai, kita tak boleh tukar. 0.62 tu kita negative log kan terus dapat dan kita kata dia basic solution. Apa-apa hal pun nak tahu larutan itu basic, acidic or neutral, kita kena kira pH. Tapi daripada table kita dapat concentration OH minus dulu. So, you kena kira pOH. Okay, you kena kira pOH. So, masukkan dalam formula ini where pOH equals to negative log 0.62 which is equals to 0.26. Sorry, 0.21. Tapi 0.21 itu bukan pH, itu pOH. Okay, yang mana pOH tu adalah negative log concentration OH minus. Kita kena kira pH. So, macam mana nak kira pH? Kita ada satu tadi perkaitan. Apa dia? PKW equals pH plus pOH which is equals to 14.00. Jadi kita sudah ada pOH. Okay. Kita boleh cari pH. Jadi pH is equals to 14 minus 0.21. So the pH of the solution is 13.79. Therefore, it is a basic solution. Okay, kalau kita nak gunakan perkaitan KW, okay, kita boleh masukkan dalam formula inilah. KW equals to concentration of hydronium ion times concentration of hydroxide ion. Ini equation ini memang dah tetap. Kita dah belajar tadi kan, auto ionization of water. And nilai ini juga adalah constant. Okay, saya padam dulu. Alright. Okey, jadi disebabkan kita dah tahu nilai KW 1.0 darab 10 negatif 14 dan daripada table kita sudah tahu concentration OH minus, masukkan. So kita akan dapat concentration hydronium ion which is 1.61 times 10 to the power of negative 14 molar. Jadi kita juga boleh gunakan kaedah ini nak tentukan acidity or basicity. Kita compare. So, from the comparison, the concentration of OH minus is greater than hydronium ion. Therefore, it is a basic solution. Jadi, awak boleh guna mana-mana cara. Nak guna KW ataupun nak guna pH. Okey, kalau tak faham, kita tengok soalan seterusnya. Alright, we have 1.4 times 10 to the power of negative 3 molar hydrochloric acid. From our prior knowledge, daripada pengetahuan sedia ada kita, kita memang tahu ini adalah acidic solution. But we have to determine, kita kena tentukan, dia ni adalah acidic solution dengan melakukan pengiraan. Paling mudah kita kira pH. Okay, so what is needed is you have to write down the dissociation equation. Tuliskan persamaan penceraian asid ini. So hydrochloric acid adalah strong acid. Okay. So, it dissociates completely. Jadi, arrow ni adalah irreversible. And it is converted to H plus NCl minus. Okay. Initially, we have 1.4 times 10 to the power of negative 3 HCl. Tapi sebelum itu, ion-ion ini belum terhasil. So, that's why kita letak 0 kat sini. Kat sini lah. Bukannya dash, zero. Kalau dash tu maksudnya kita ignore. Disebabkan HCl ini adalah strong acid, dia akan completely dissociate. Dia terus habis. So, the final concentration of HCl is 0. Okay, and the concentration of H plus is 1.4 times 10 to the power of negative 3 and Cl minus 1.4 times 10 to the power of negative 3. Daripada table ini, kita sudah ada concentration H plus. Jadi, saya dah bagi clue tadi, kita kira pH. Kira pH of the solution. Macam mana nak kira pH? Inilah formulanya. pH equals to negative log H plus. Ataupun mungkin ada guna water dalam equation tu, kita boleh guna pH equals to negative log concentration of hydronium ion. Okay, masukkan nilai 1.4 times 10 to the power of negative 3 into the formula. You will get the pH around 2.85. Jadi, kalau pH larutan acidic itu, dia mesti kurang daripada 7. Therefore, as a conclusion, HCl is an acidic solution. Okay, now, alright. Okay, kita pergi kepada soalan yang seterusnya. Kita nak tentukan acidity, basicity of distilled water. Distilled water, bahasa Melayu, air suling. Jadi, distilled water ni adalah water juga. chemical formulanya water. Okay, H2O liquid. Jadi, of course kita nak tentukan pH distilled water, kita kena kira. Maksudnya nak kira pH mesti ada concentration H plus ataupun H3O plus. So macam mana nak jawab soalan ini? Kita baru belajar tadi bahawa water undergoes auto ionization. So nak guna equation yang ini pun boleh. The dissociation equation ataupun auto ionization of water, ataupun you boleh tulis equation yang ini. H2O liquid, okay, dissociates into ion, okay, and forms hydronium ion aqueous plus OH minus aqueous. Okay. So, daripada equation ini, we know that the Kw is the ion product constant of water, which is equal to the concentration of hydronium ion times concentration of hydroxide ion. Okay, dapat satu nilai constant which is 1.0 times 10 to the power of negative 14. Dan tadi saya dah ajar bahawa dengan menggunakan matematik, ini adalah x squared, okay, x squared which is equal to 1.0 times 10 to the power of negative 14. So, you akan dapati bahawa x sahaja, yang mana x adalah concentration of hydronium ion, dan dia juga adalah concentration of hydroxide ion. Selesaikan secara matematik. The concentration of hydronium ion is 1.0 times 10 to the power of negative 7 molar. Jadi, nak kira pH, the formula is pH equals to negative log concentration of hydronium ion. Jadi, berapa concentration hydronium ion? Ini tadi. So, masukkan dalam formula negative log 1.0 times 10 to the power of negative 7. Okay. So, you akan dapati bahawa the pH is 7.00. Therefore, the solution ataupun distilled water adalah neutral. Alright. Okay. The last question. A Bronsted base is a base that can accept proton H plus from the acid that reacted with it. The table below shows the base ionization constant Kb for several selected compound. Jadi, yang diberikan dalam table ini adalah semua ini, kalau ada nilai Kb tu, ini menunjukkan weak base. Semua ni adalah weak base. Jadi, setiap weak base ada nilai Kb masing-masing. So, how we are going to use Kb values to compare the relative strength of basicity of a base. When the Kb value is greater, it is a stronger base. Kalau nilai Kb itu makin besar, maksudnya di kalangan weak base ini, dia adalah stronger base. Jadi soalan minta arrange the compounds in order of increasing strength of base. Daripada the weakest base goes to the strongest base. So the weakest base, kalau you refer Kb value, goes to C6H5NH2, followed by NH2OH, next N2H4, and the strongest base goes to ammonia, as it is. Okay. Jadinya sekarang, sebelum kita bincangkan soalan seterusnya tu, kita kena faham dulu. Sebab soalan tu minta apa? Give the structure of conjugate acid for each compound and arrange them in order of increasing strength of acid. Okay. Saya cadangkan nak jawab ni sebab you kena practice. You kena fahamkan sambil nak buat tutorial. Okay, buat table. We have compound. Compounds given. And you nak jawab apakah structure conjugate acid bagi setiap compound tersebut. So, yang ini adalah apa? Weak base lah kan? Okay. Apa tadi compound yang kita ada? We have C6H5. NH2. We have NH2OH. And then we have N2H4. Betul ke? Okay, we have 4 compounds and we have ammonia. Okay, jadi according to Bronsted-Lowry, weak base ataupun base, it can accept a proton from other substance. Jadi selepas compound yang pertama ini accept proton, proton tu dia nak tambah kat mana? H plus tu nak tambah kat mana? Dia akan bind dengan nitrogen kat sini. So it will form a conjugate acid. So what is the structure of the conjugate acid? C6H5 and H3 plus. So nampak bilangan proton makin bertambah and the charge become more positive. Same goes to NH2OH. It will accept proton because it is a base according to Bronsted theory, and dia akan tambahkan proton itu kepada nitrogen ini. So the conjugate acid is NH3OH plus. N2H4, it will accept a proton and it forms N2H5 plus. Bilangan proton mesti bertambah and the charge become more positive. Okay, charge dia bertambah satu positif lah daripada compound asal. Okay, and we have ammonia. Bila ammonia ni adalah base. Jadi according to Bronsted theory, ammonia accept a proton from other substance dan dia akan form NH4 plus. So, ini adalah jawapan bagi structure of the conjugate acid. Okay, the weaker the base, lagi lemah base tersebut dalam soalan ini, the stronger its conjugate acid. Tadi, okay, kalau kita lihat soalan seterusnya, ini adalah susunan increasing strength bagi base tersebut. Jadi sekarang kita nak susun conjugate acid bagi base ini according to increasing strength of acid. Jadi base yang paling lemah, conjugate acidnya adalah yang paling stronger. Jadi kalau kita refer kepada yang kita dah buat ini, maksudnya ke sini, ke bawah ini untuk base, dia adalah stronger base. Mana datang? Kita tengok nilai KB tadi kan. Tapi sekarang pasangan conjugate itu dari segi strength itu terbalik. Maksudnya ke bawah ini dia adalah weaker conjugate acid. Jadi sekarang kita kena susun increasing strength of conjugate acid. Okay. Jadinya start daripada apa? Start daripada increasing strength. Daripada yang paling lemah lah. Ammonium ion NH4 plus is weaker than N2H5 plus is weaker than NH3OH plus, and the strongest goes to C6H5 and H3 plus. Okay, so ini adalah soalan tutorial for the first hour. Bukanlah first hour, second hour lah. First hour hari tu yang online tu kan. Jadi saya akan beri video lah macam ni untuk pelajar-pelajar di rumah. Kalau tak faham, tolonglah tanya. Okay, alright class, thank you.